Hi, my name is Victor Witek, metric number AF200134. We are from Section 6, Group 4, for subject Engineering Geology. My group member consists of Chen Hui Min, Zhong Hui Ling, Tan Min Kai, Goh Zhengzi, Lin Chunyi, me, and Muhammad Farhan Haziq bin Abdul Rajah.
Hello, this is Chen Hui Min. Now I'm going to explain the activities we've done in this project. The first activity is to determine rock and minerals that are available in the study, and the second activity is to identify and classify the weathering rates of rock outcrops, and the third activity is to investigate the geological structure that form in the study area. The minerals in the field can be examined with naked eye and performing simple tests such as crystal form and shape, strip, color, luster, cleavage and fracture, hardness, and density and specific gravity. This table can help us to identify and classify the weathering rates of rock outcrops. Grade 1A is fresh, Grade 1B is thinly weathered, Grade 2 slightly weathered, Grade 3 moderately weathered, Grade 4 heavy weathered, Grade 5 completely weathered, and last, Grade 6 is residual soil. Let me take some example. In Grade 3, there is less than half of rock material in a degraded condition, while in Grade 4, more than half of the rock material in a degraded condition. To investigate the geological structure that form in the study area, there are three types of deformation. The first one is fractures. Faults are fractures which have had displacement of the rocks along them. The adjacent rock masses slip past one another in response to tension, compression, or shearing stress. There are four categories of faults, which are normal fault, reverse fault, lateral fault, and oblique slip fault. The second one is joints. Joints are rock fractures with no movement along them and tend to break a rock mass into a network of blocks. They are formed by tectonic stressing and are developed in nearly all rocks. The third one is faults. Faults is a bend or flexure in layered rocks. It is the most common kind of deformation in layered rocks, usually where collisions are developed in great mountain systems. There are three categories of faults, which are monocline, anticline, and syncline.
I'm Chong Hui Ling. Now I will continue to present about the activity. The next activity is to learn how to conduct a scrimmage test, and then to determine the rock mass quality using the rock mass rating R&R, and then the last one is to learn how to use the Proton Compass and scan line survey. The first one, scrimmage hammer test, is used for test rock of a large range of the unitious compressed stress (UCS), and there are two types of hammer, which is L-type and N-type hammer. For the L-type hammer, the impact energy is 0.735 Newton meter, and it is greater sensitive in the lower range and gives a better result when testing weak, porous, and weathering rocks. And it is ideal option for testing work item with a thickness between 50 to 100 mm. And for the N-type hammer, its impact energy is 2.207 Newton meter, and it is less sensitive to the surface irregularity and should be preferred in field application. The rebound values are read from a scale for subsequent calculation of the mean, and its compressed strength value can be read from a conversion diagram. These two pictures is the example of the hammer. For the rock mass quality, there are 6 parameters for classifying the rock mass by using the R&R system. The first one is the unit-axial compressing strength of the rock material. Second is the rock quality designation (RQD). The third one is the spacing of discontinuity. And the next one is condition of discontinuity. And fifth is the groundwater conditions. And the last one is orientation of discontinuity. And the diagram is the rock mass rating system. For the rock mass rating system, there are 6 parts. The part A is the classification parameters and their rating, and part B is the rating adjustment for discontinuity orientations. For the part C is the rock mass classes determined from total ratings, and the part D is meaning of rock classes Part E is the guideline for classification of discontinuity condition, and the last one, Part F, is the effect of discontinuity, straight and deep orientation tunneling. For the last activity, which is to learn how to use the Proton Compass and Scanline survey. The Brundon Compass we use to collect the geological data and to analyze the rock slope. And this picture is the Proton Compass. Actually, for the geological compass, there are three types. The first one is the Proton Compass, second is Geological Stratum Compass, and the third is the Kirkham Small Stratum Compass.
Hi everyone, my name is Tamin Kai, metric number AF200130. Today, me and my friend will continue to present the test that we are carrying out on the study site. First of all, let me start with Smith hammer test. Smith hammer test is also known as rebound hammer test. It is a non-destructive technique that is used to determine the compressive strength, surface hardness, and penetration resistance of reinforced concrete and masonry structure by measuring the rebound of a spring-loaded masses impacting against the surface of the sample. The hammer hit the surface at a defined energy, and it will give us the compressive strength value of the sample. The method starts when the hammer was pressed against the rock. The plunger reacted against the spring and the hammer was ready to be used. Next, the hammer was pressed to the test location until the mass hammer impact against the surface through the plunger. The hammer was operated perpendicular to the surface horizontally. After that, the button at the side of the hammer was pressed and the amount of the rebound of the mass R from the indicator was read. By referring to the calibration curve on the standard level anvil, the compressive strength was read. Lastly, we have to estimate the compressive strength with refer to the table given. That's all from me. I will pass to my teammates. Thank you.
Salam Shakti to Doctor. My name is Goh Zeng, metric number AF200146. Today I would like to present the part rock mass rating method in our project. First, the process of window with 1 meter multiplied by 1 meter rock is used to obtain the classification parameters and their ratings. Second, the number of joints for each joint set is recorded to determine rock quality designation and average spacing of continuities. Third, the condition of continuities is determined based on the persistence, aperture, roughness, and weathering. Next, the groundwater condition is observed by neck ice and touched by hand where the rock mass is completely dry. Fifth, the orientation of the discontinuity is determined. And the last is the data collected is classified based on the rock mass rating system to determine the total rating of the rock. That's all from me. Thank you.
Good morning, Doctor. My name is Lian Chunyi, and I will present the collection discontinuities data by using Brundon Compass. Firstly, a rock mass is selected to determine different types of geological structure at Air Item, Johor. The deep direction is measured by using the side of the compass against the plane of the outcrop. The compass is fixed and rotated until the blue ice level bubble is centered. Then, when the compass is horizontal against the plane and parallel to the line of the strike, and now the deep direction can be recorded. Dip angle is measured and make sure that the dip line is perpendicular to the strike line. The compass is fixed and rotated until the blue ice level bubbles is centered. The dip angle is recorded. Lastly, the step 2 to step 4 is repeated to collect 30 points of discontinuities data of dip direction and dip angle. That's all is my presentation. Thank you very much.
Now it's my turn to discuss the finding of our case study area. The rock that found at the study area is the sedimentary rock. The picture clearly shows that the rock is deposited layer by layer is the characteristic of the sedimentary rock. The mineral of the sedimentary rock is commonly came from quartz and feldspar. Picture beside shows that the weathering grade of rock outcrop for sedimentary rock. The weathering classification system is done by Annan in 1977 for sedimentary rock. This system is classified into 7 categories of rock, which are residue soil, completely weathered rock, highly weathered rock, moderately weathered rock, slightly weathered rock, fleshy weathered rock, and the last one is the fresh rock. The weathering of rock at our case study area is determined. There are 4 types of grade that evaluated in our case study area, which are grade 3, 4, 5, and 6. It can be clearly shows that at the picture beside. From our case study area, there are a few geological structures that can be determined, which are fault, fold, bedding, and joint. First, fault is determined at the case study area. Fault is the displacement of the rock along them. It consists of crack with the movement of rock. Fold is the bend or fracture in the layer of the rock. There are two categories of fold, which are anticline and sincline. The anticline is the up arc rock with the old rock is at the center, while for the sincline is the downward rock, which the center rock is the youngest rock. Bedding is the arrangement of rock which in the layer by layer. This is due to the process of transportations and depositions. Joint is the fracture of rock without movement, but it tends to break into network of rock. In addition, we perform the skin hammer test at our case study area. The reading of hammer rebound at post B that we get at the average is 25, and later on we convert this value into unit axial compressive strength UCS by using the graph. The graph of reading of rebound hammer against the unit axial compressive strength is represented beside.
Hi, so I'm Muhammad Farhazi bin Abdul Rajaf. I will be continuing the further findings for our group project. So for determining of rock quality designation, we will first determining the number of bedding, the number of vertical, the number of incline and fractured surface on our 1 meter and 1 meter sample. After determining all the sample, we must calculate the RQD using the formula, and the RQD that we have determined for our sample is 2.8%. After getting the RQD, we will determine the spacing using the formula above, and for our sample we get a spacing of 0.201 meter. So after that, for the table above, the table shows the characteristic of our sample in 1 meter and 1 meter. We have got the uniaxial compressive strength, which is the value of 19 Newton per millimeter squared, the value of RQD, which is 2.8%, the spacing of discontinuities, which are 0.201 meter, the condition of discontinuities, which are at the rating of 8, and our groundwater, which are dry according to our bare hands. So the total rating for our case study area is 38, which is determined by poor rock. This is the Brundon Compass data that we have put in a table, for which there are 30 samples that we have been found on the site. The data shows deep direction and deep angles as such on the tables above. Okay, so after conducting all the tests such as RMR, such as rebound hammer test, we have found the type of minerals and rock, and we able to determine the grade of weathering on the soil given. So for us as a student, we have found a ways to find how we can determine the minerals and rock using such method. It is a great pleasure to have conducted the group project all together within a group, and we all work together nicely to complete all the project requirement. Thus, we have determined the subject objective to teach us on how to learn and categorize the minerals and rocks all truly. Okay, I think that's all from us. Thank you and have a nice day.